Hello, everyone. Good noon, good evening. My name is Rupesh Share. I'm a cloud security architect. In our today's webinar session, I will just walk you through the Azure vWAN functionality and how Checkpoint CloudGuard can be ingested into it, and how we can create a secure Azure vWAN service for our customer. Okay. So today's session would be pure technical session. It's kind of level 200, level 300. Okay. And we'll focus on hands-on lab today. We'll go through the configurations. Okay. How exactly we can do integrations at the Azure vWAN level, how we can do the peering. Okay. So please be stay with us. Okay. So it would be a fun. We'll see the actual labs in our environment. Okay. Uh, Before getting into the presentation, I just wanted to walk you through the agenda, what exactly we're going to cover today. I'll just give you a brief about Azure vWAN, short. Second, I'll talk about the CGNS integration, CloudGuard network security integration along with Azure vWAN, how simple it is to do the integration and ingest the security into your hybrid vWAN architecture. What would be the reference architecture? Okay. Then we'll go deep into our labs. Okay, we'll see the actual configurations, and lastly I will open up this particular session for question and answer. Okay. You can post your queries in chat window, and at the end of the session we will try to address all of your queries which we have. Okay, we are good. So let's dig into it in our presentation. So the first and most important, what is vWAN? Okay, I just wanted to clear the concept here, what Microsoft trying to do here, and what kinds of problem statement they wanted to address with the new service called Azure Virtual WAN. So if you ask me, it's a framework, okay, which has managed networking and managed security services, managed services baked in into it. Okay. uh, where you can terminate any kinds of connectivity into the Azure vWAN hub. Obviously, it's a hub and spoke kind of architecture where you can configure multiple kinds of connectivity together within that particular hub, and you can manage the multiple connections together in a more simplified manner. And if we talk about connectivity, let's understand what kinds of connectivities we can configure within the Azure vWAN. Obviously, the first, all your VNet peering, where your Azure application is getting configured onto it. You can peer your respective VNets with the hub. Second would be SD-WAN connectivity. So you can configure your SD-WAN appliances within the hub, and you can build the SD-WAN architecture from branch to DC. Then VPN connectivities, both kinds of VPN connectivity, site to site VPN as well as remote user VPN. So, and I can see this is again a big use case as well. Okay, and the scalability which they are offering together, Checkpoint and Microsoft offering is really huge. And plus the private connectivity like express route connectivity also we can manage it via single hub. So everything can be combined within the same hub, all the networking configuration present within that, and we can manage the entire network operation through centralized console. So if I'll simplify this, it's kind of framework, as I said, which is Microsoft is trying to provide a managed networking and security services with one common goal: operational excellency. Okay, that is what Azure vWAN in very few words. So now the let's talk about security insertion. We talked about connectivity. Now talk about security insertion. How exactly we can insert a security. So we understand the data path. Okay, what kind of connectivity gets configured within the Azure vWAN hub. Now how we can secure those particular data path. And the question is how easy it is to do that. Okay. So Checkpoint has out of the box integration with Azure vWAN. It's a single click kind of deployment with single button. Okay. So we have a NVA, network virtual appliance, which can place at the center of the hub or vWAN fabric. Okay. And all kinds of connectivity which is hitting on the Azure vWAN. So it will get inspected by Checkpoint firewall automatically, and it supports multiple types of traffic flows, and we will discuss those particular traffic flows in our coming slides as well. And the Checkpoint is the native vendor here, where we have a, as I said, out of the box integration with vWAN hub technology. Now let's talk about those particular traffic flows. How we can inspect your multiple traffic flows, how we can inspect the multiple data path which is hitting on our central hub. Okay, and how easy it is. So I prepared one particular deployment for you. So if you see below, there are multiple branch location. I'm taking a multiple scenarios here. So customer has a multiple branch location with SD-WAN, without SD-WAN. There would be a remote users who's might be working from home or on the road users. Um, there are virtual network VNets. That is where the application is configured, and these branch users as well as remote users trying to communicate with that VNet where the application is hosted. Okay, so we can build one vWAN with vWAN hub architecture, and we can insert a checkpoint NVA within that center of the vWAN hub, and so we can initiate a communication from branch location to another branch location. Okay, which is east west kind of communication, which is the first traffic flow. One VNet to another VNet, one branch to another branch. Okay, or one user to another branch, vice versa. Okay, so we can insert that particular communication, and we can inspect that particular data path via checkpoint NVA. That's the first network flow. Second flow would be your north-south traffic. Your branch users try to communicate with the application which is hosted on Azure VNet. Plus your remote users as well who wanted to communicate with your Azure applications. Or plus vice versa. It's a bi-direction, which I'm talking about. So normally branch to Azure VNet, it's a bi-direction, vice versa. But your remote user to VNet, it's a unidirection traffic. So your application server usually sends a response back towards your remote user. Okay, so that is what north-south branch scenario or traffic flows. Third would be the central internet breakout. So here we can use the existing NVAs, or we can configure a separate NVA within the same hub. Okay, and we will use that particular NVA to create a central breakout. So if any users or any applications or any VMs which is present in your Azure VNet, or might be in your data center, or any users which is present in your branch as well as remote user, if they wanted to access internet, google.com, microsoft.com, or any xyz.com. Okay, so we can redirect that particular traffic towards the Azure vWAN hub. First, the traffic will get inspected by checkpoint firewall NVA, which is configured at the center of the hub, and then based on the inspection policy, the traffic will get allowed or denied, or plus it will send that traffic towards the respective domain, and it will okay. So that's a central breakout use case, and which is very common and is which is applicable for each and every kind of environment. Second, there would be a scenarios where we have to configure multiple hubs. Specifically, I'm saying one scenario where if you wanted to deploy multiple vendor devices. Okay, right now you can't deploy multiple vendor devices within the same hub. So might be SD-WAN. So the security is from checkpoint, firewall you deployed, SD-WAN you wanted to deploy some XYZ vendor. So in that case, you have to create a separate hub altogether. Okay, so that might be another scenario. Or there's other scenarios where we have to configure multiple hubs. Might be we have multiple regions. So region wise, we have to create hub. So in that case, we even inspect inter-hub traffic as well via checkpoint firewall. Again, I'm talking about east-west traffic flow inter-hub. So if I have a two hub, okay, and there's one VNet which is associated or paired with virtual vWAN hub one. There's another VNet which is paired with vWAN hub two. So in that case, if both the VNet wanted to communicate together, so we can do that particular insertion as well. Okay, that's another use case. Next, obviously, the north-south traffic inter-hub. So users wanted to communicate with other VNet, which is paired with vWAN hub 2. Okay, so that traffic also we can able to inspect. So which is the fifth traffic flow. Okay, and last but not the least, our express route connectivity. Okay, so which is the private connectivity. So we can configure express route on the vWAN hub, okay, or any traffic which is coming from your on-premise data center towards the Azure VNet. We can able to inspect that particular traffic, which is the last traffic flow. So I prepared one particular table and which I'll share with you how inter-hub and cross-hub traffic flow supported by checkpoint firewall. Okay. Let's dig into some reference architecture, and then we'll go to our actual lab sessions as well. And just understand the traffic flows as well, hop by hop, how exactly it is happening in actual scenarios as well. So the most common architecture is single hub architecture. Okay, so here uh, we configured one hub within the vWAN architecture, and within that we insert a checkpoint NV appliances. Okay, and this particular hub has a multiple network data path. One is your VNets, so your VNet 1, VNet 2, VNet 3. That is where your actual application is hosted. So we pair that particular VNet with vWAN hub. Okay, plus there is a express route connectivity also gets configured on the same vWAN hub. So the traffic which is coming from your data center or the traffic which wants to go towards the data center also gets land and configured on the same hub one. And there is a scenarios we have a branch one, branch two. Those are communicating with Azure environment with the help of site-to-site VPN tunnels. Okay, that's a third network configuration. Fourth is the point to site VPN, which is the user VPNs. Okay, we also terminated user VPNs for roaming users also on the hub. So those roaming users can able to access the applications which is deployed in VNet 2, VNet 3. Okay, and currently, if you see the vWAN hub architecture, okay, so in vWAN hub architecture, uh, uh, only one use case is currently not EA, currently not GA or general available, which is the ingress use case. So if I wanted to inspect applications, the incoming traffic or user web traffic, okay, currently it's not possible because there's no actual external load balancer gets configured when we deploy NVA within that particular hub. Okay, but we'll discuss about what exactly the workaround for that particular traffic, ingress traffic workaround. So we can configure another ingress hub, which is VNet 1. That is where we can configure checkpoint firewall in a scale set mode. And that is where we'll deploy the external load balancer, either application load balancer or network load balancer. And you can expose those applications, okay, or via the A records or CNAME records of respective load balancer. Okay, so let's understand the basic traffic flows as well for your incoming traffic flow, where the end users or customers wanted to access your xyz.com, which is configured in VNet 2, VNet 3. So we expose those applications via the load balancer public IP. We maintain the records in the DNS. So the xyz.com will get resolved via external load balancer. So traffic will hit on external load balancer. So external load balancer has a backend pool, which is the checkpoint VMSs. Okay, so traffic external LB will send that traffic to checkpoint VMSs gateway. Okay, checkpoint VMSs gateway will do a hide NAT here. Okay, and it will send that traffic towards hub because we did the peering, this ingress VNet peering with hub. Okay, traffic will go to the hub, it will do an inspection and it will send that traffic to your respective VNet 2. That is where your application is hosted, xyz.com. Okay, we will see this particular use case in our actual lab, how exactly we can configure that. Okay, and plus I'll also talk about the ingress traffic support for vWAN, what exactly is the roadmap. Okay, that's the ingress traffic flow. Second would be the egress traffic flow. Egress traffic flow means this VNet 2 wanted to access internet, google.com. So in that case, we paired VNet 2 with hub again. So all the traffic will hit on front-end IP of internal load balancer, the default traffic first of all. That internal LB will send that traffic to CGNS, NVA, which is scale unit. Okay, any one of the gateway firewall. Firewall will do inspection, and firewall has route, internet route pointing towards the internet. Okay, so that would be a egress traffic flow. And the return packet again will come back to CGNS firewall because obviously there would be hide NAT as well. Okay, and then because we are doing hide NAT, CGN is going to send that traffic directly to VNet 2, which is the response packet. It will not go back to internal LB. Okay, and last, which is VNet to VNet traffic. Okay, so this VNet 2 wants to communicate with VNet 3. So in that case, again, the default traffic is pointed towards the internal LB front-end IP, and it will send that traffic to CGNS, any one of the NVA. Firewall will inspect that traffic and it will send that traffic back to VNet 3, and the response packet will come back. It follow the same direction. So that would be a north south and east west traffic flows in this particular architecture in single hub. Let's go into this second hub architecture, which is, we can configure two hub. As I said, right now, if there are two vendors, okay, one vendor belongs to SD-WAN, another vendor belongs to security. So right now we can't configure two different vendors, devices or NVA within the single hub. So that's why we have to configure multiple hubs here. So here, if customer decided to configure SD-WAN as well along with vWAN hub, so for SD-WAN, we can create a separate vWAN hub with obviously within the same vWAN fabric. Okay, and that is where we can configure the SD-WAN appliances, and all your branches, SD-WAN branches, can have a communication with that vWAN controller or gateway, SD-WAN controller or gateway. Okay, and that SD-WAN gateway has hub as a communication with hub 2. That is where checkpoint firewall gets deployed. So that is actually a two hub kind of architecture. So inter-hub communication. So what we discussed in our previous slide. Okay, so these are most two common architectures we are seeing, which customers are adopting across the verticals. Okay, and if you ask me here, what exactly we are offering, okay, what key differentiators or key use cases for customers, and what key benefits customers are getting with this particular architecture. First of all, simplified networking, because we are managing any to any kind of connectivity via single vWAN framework. And because it's a managed service, the extra overhead on operation is getting reduced because of that. Okay, there's something called intent route concept, okay, which I wanted to show in live how exactly it works, because you're fully aware about UDR concept. UDR, that is where we define the static routes, obviously, plus the dynamic routes also gets populated. But I just wanted to show the intent route feature of vWAN, and then you will understand how easy it is to configure routing within the vWAN hub framework. Okay, so it's a managed networking service. So, and eventually it will help to improve the overall operational efficiency. Okay, that is what any to any communication. Again, second one would be the simple insertion of security. Again, I will show you in real lab how exactly this is happening, how easy it is to insert a security within the vWAN framework. Third, I can see another use case is global coverage of VPN, user VPN connectivity, and the scalability, because the hub can be configured across regions globally. Okay, and we can configure or terminate multiple numbers of SSL VPN or user VPN on top of it, which will add a lot of scalability to create a global VPN service for our customers. Okay, so these three unique points or key differentiator I can see if we integrate, or if we adopt vWAN and integrate checkpoint firewall into it. Okay, now let's talk about some other points, and then we'll dig into our architecture in our lab session. I will just show my screen, Azure screen, and we'll go through the configurations one by one. Okay, so I just wanted to talk about some timeline first. This particular service, is now GA. So the it's a quarter back. The service GA now. Okay, and we also talked about one use case which is currently not doable in vWAN hub architecture, which is the ingress traffic inspection. Okay, the good news here is the this particular inspection is now EA, and we are inviting customers to test this particular service. Okay, how easy it is even to inspect your incoming traffic flow. So with this, our entire traffic flows, our entire use cases will get covered, and it will fulfill most of our customer requirement. Next, right now for checkpoint per se, currently the minimal version we do support is R81.10, and the latest version what we do support is 81.20. That we have to keep in mind. So if customer wants it to deploy 8.40 or 81, right now it's not possible. Minimal version is 81.10 only. Then the support, that is again one of the key point, which is why we have to opt out for vWAN service along with CGNS security insertion, is the streamlined joint support. Okay, so here you can open a ticket with Microsoft first, and then we can have a coordination with Microsoft, and we together try to resolve your queries. So we are both are committed, Microsoft as well as Checkpoint, to resolve any kinds of queries or any kinds of business impact. Okay, and the most important part here is because we are in conjunction, so we are trying to resolve our queries. We are resolving queries much more faster. Then the another most important aspect. What is the licensing model? So the licensing model here is the consumption based licensing model. It's a pay as you go. Currently, BIOL is not possible. Okay, it's a pay as you go consumption based module. Okay, and we have to do it via Azure Marketplace. Next, upgrade and the performance. I will talk about upgrades and performance in actual scenarios, in actual labs scenarios, how we easy upgrade procedure is. Okay. And last but not the least, the roadmap. So two important thing: SD-WAN support is coming up very soon. Stay tuned for that. And like side-to-side tunnel configurations. Currently is also possible, but there are certain limitations into it. But we committed to our customers, okay, to provide more enhanced security services. Okay, so that's it for me in terms of slides. I don't have much slides, and I will not gonna bore you with other theory content. So what we can do it further, we'll just dig into our lab. Okay, but just before that, I just wanted to show you the architecture, what exactly I configured in my environment. Obviously, it's a pre-configured, but I will walk you through the entire configuration. So if you see the architecture here, so I created one vWAN hub, okay, and that is where I configured a single scale unit, okay, along with the internal load balancer gets configured automatically here. Plus, I also configured one more set of NVA because I just wanted to show you some other use case as well. Plus, there are two VNets which I configured, okay, app VNet 1, app VNet 2, and I pair that particular VNet with vWAN hub. Plus, for ingress traffic flow, I configured one more VNet, which is my ingress hub or northbound VNet. That is where I configure checkpoint firewall in a VMSS mode. Okay, and I expose my applications via public IP of load network load balancers. So currently, I configured network LB, but obviously you can configure application load balancers as well. Okay, and plus I configured checkpoint management server, uh, okay, in another VNet. The communication between my checkpoint management server and all my virtual appliances is over an internet. Okay, so this is what my high level architecture. Now what we'll do, we'll just dig into the first vWAN architecture. Okay, how exactly I configured, how I inserted the checkpoint uh, NVA within that hub, and we'll also see the traffic flows. We'll try to simulate multiple traffic flows here in our live environment. Okay, so please allow me to share my screen as well, entire screen. Let me just do that quickly. Hope my screen is visible to all of you. Yeah, and my so I logged in into my Azure. Okay, so this is what the vWAN I configured. Okay, checkpoint vWAN. So within checkpoint vWAN, I already configured a vWAN hub. Okay, if I get into this vWAN hub, okay, let me just go there. Okay, it's a straight forward configuration. Nothing much is there to configure vWAN hub, vWAN and vWAN hub. It will take somewhere around 20-25 minutes approx because in backend they're building a complete managed network for you. Okay, and this vWAN hub we paired three VNets. Okay, total. So I can just show you that three VNets as well, which I paired. It's under virtual network connections. So I paired three VNets, the my app VNet 1, app VNet 2, and my ingress VNet. Okay, so the routes, the effective route will get configured automatically for you. It take few seconds to pop up the VNet connections. I just wanted to show you. That's right. And plus, if you see the other connectivities, okay, so we can configure multiple hubs as well. Right now, only one hub is there. We can configure VPN sites, both site-to-site VPN as well as user VPN. Okay, here. Then plus we also able to terminate the express route connectivity as well. So everything, okay, my CP vWAN connectivity has five different options. So VNet, express route, my user VPNs, and obviously my hub. So if you see, this is what my hub. Right now, only single hub is there, but I can configure multiple hubs. And these are my peered network. My spoke VNet 1, spoke VNet 2, that is where my applications are configured. And this VNet 01, this is my ingress VNet. That is where I deployed a checkpoint VMSS gateway. Okay, so I peered, so the route gets exchanged. BGP gets configured between those VNets. Okay, and default route gets pointing towards the vWAN hub net. Okay, so only for VNet 01 for egress, I configured a static route, which is one UDR I configured. Okay, and my default route I'm pointed towards the internet, and I'll tell you why as well, why I did that. Okay, and if you see my hubs as well, so right now only single hub is there, but you can configure one more hub. Okay, you can mention what kinds of connectivity, site to site, point to site, express out. Okay, and then you can able to configure your hub is nothing but actually in backend it's a VNet. Okay, but it's a managed VNet, so you can define your address space, private address space for your hub. Okay, what kind of hub routing preference is required, express route, VPNs, path. Okay, and you can configure your multiple services. This is how you can configure your hub. Okay, so usually to populate the entire routes, okay, after configuring hub, it takes 15 to 20 minutes minimum. Okay, so within hub now, let's go inside the hub. So let's understand first the routing aspects of hub. So as I said, normally if you go to normal VNet, there is a UDR concept, correct, where we can configure multiple static routes, custom routes. First of all, in hub, because it's a managed service, there is no UDR concept. Okay, you're not able to configure any specific custom routes within the hub. Okay, so what options we have? So it called routing intent as per the Azure terminology. Okay, and routing intent is simple, very much simple. Okay, so right now there are two kinds of routes. Okay, one is the internet traffic. So as I said, the egress use case or central breakout use case. So we'll say if anyone, any user or any application or any branch wanted to do a central breakout and wanted to access internet, then what would be the traffic flow? And obviously I need to do a network insertion, security insertion as well. Okay, so I mentioned if any traffic destined towards internet, which is the internet traffic, go towards NVA. So I configured NVA and I'll show you that as well, but just understand the internet traffic. Then my next hop, so this is what my NVA. Oh wait, that's the first kind of traffic, okay, which is actually GA for all our customers across regions. Second kinds of traffic is private traffic, okay, which is your RFC 1918 ranges. Okay, so in that case, all your private IP range 192, 168, your 172 series, 10 series. Okay, if the destination is those RFC 1918, okay, we'll say send that particular traffic again for inspection purpose. That inspection is what? The check, this firewall inspection, which is network virtual appliance inspection. Okay, so we did that. So the third traffic flow, which is our incoming traffic flow, which is missing right now. So that's why in we configured a separate VNet altogether. But that particular feature is in EA, and as I said, we are inviting our customers to test that particular feature. Okay, so this is what routing intent, only two routes and simple. We don't have to manage multiple routing, multiple UDR controls. No, not required at all. Everything is getting managed by a job for you. Simple, is it? Now, the most important part of our conversation, the network virtual appliances. Okay, so this is where you can do a security insertion, or not just security insertion, but even if you wanted to deploy SD-WAN as well. So currently I configured two scale unit, and I'll talk scale unit, what exactly scale unit is. There's always a question and the difference between what is scale unit and scale sets. Okay, I'll cover that particular confusion as well. Okay, but just understand the configuration, how exactly we can insert a security within the vWAN hub. Okay, so there's a third party provider. Under third party provider, NVA setting is there. I can go to add network virtual appliance, and right hand side you will see the window, and it will show you the support, which vendors currently uh, uh, can able to ingest services within the vWAN hub. There are very few vendors, few security vendors first of all. There are SD-WAN vendors are many, but security vendors are few. Only Checkpoint and 14 it is here. Okay, so here I can go to Checkpoint. I can select Checkpoint and then create. So it will redirect me to the marketplace. Okay, and which has the vWAN image. And here, so option is CloudGuard gateway. I can just simply click on create. You can define vWAN resource group. So vWAN test. Let me just see. Yeah, it is there. I can mention that. You can define your region where exactly your hub is configured. My hub configured in central US region. So that's why I'm mentioning that. This setting is important. Manage application details. Okay, so you have to note it down your manage resource group and manage application name as well. So NVA, you can just name it anything, manage app. Okay, and you have to note it down this. Okay, and we will use this for CME. Checkpoint has a concept called CME, where we automate the onboarding job on our management server. And I will show you that as well, how exactly it happens. Okay, then if I'll go next, here you have to define your hub. In which hub we have to configure the checkpoint firewall, NVA. So this is what I have, only one single hub, so that's why it's showing one hub. So name of your NVA, you can just, so if I'll say I'm gonna use this NVA for egress traffic, egress test NVA. Now come to this scale unit. That is again most important thing. So if you see that the throughput what we are supporting. So NGTP throughput what we are supporting right now is still 40 GB PS, and for NGFW it's somewhere around 50 Gbps throughput we are supporting, which is really huge. Okay, and there are multiple scale units. So in this scale units we have two NVA. The first, second scale unit we have a four NVAs. Like that, up to we have a 80 NVAs within this single scale unit. Okay, and entire configuration, underlying platform configuration is going to manage by Azure automatically. We don't have to manage the backend encryption, or the specific update. Okay, everything, infrastructure or platform layer is going to manage by Azure. We just need to mention what throughput I need. Okay, I need.
Hi, everyone. Don't go away. We seem to have lost Rupesh. I will check to see where he is and update you as soon as I find him. It's possible that he's suffering from an internet issue, but let's wait and see. so far, I hope that this has been interesting for you. I sent a message a little bit earlier on the Bright Talk channel that if you have any questions to Rupesh, please to add them into the panel at the bottom of your screen. And we'll be very happy to receive any suggestions for future webinars or any additional feedback that you have. Still waiting to see where Rupesh is. I'll see if I can connect him offline. 1 second. I see that Rupesh has rejoined. Rupesh, everything okay?
Yes, I think Bright Talk got restarted. Not sure what happened.
Okay. Just talk again so we can make sure that we hear you, because you got cut out in the middle.
Yep. Let me just share my entire screen again.
Yes, please. I hope that I was trying to entertain the rest of the people on the call while you were away. I hope I wasn't didn't say anything silly.
Apology team.
No,
Not sure
no.
what happened to my Bright Talk. Okay, so this is how. Okay, I think I was on the Azure. Okay. So let me just quickly repeat this step. I'm just creating a resource group and my region. I'll quickly move over it. Okay, my vWAN hub. You can define any NVA name, and that is what we were on scale units. Correct. So the question here is, what is the difference between scale unit and scale set? Okay. So first of all, this scale unit, these two NVA, 4 NVA, these are not a dynamic object. These are the static object. Okay. And scale set, as you know, it's a dynamic object. That's one of the major difference, first of all. Okay. And here right now, the throughput is already predefined, okay, by Microsoft and Checkpoint together. Right now, we can go up to, within single scale unit, we can go up to 40 gig of NGTP throughput. Okay, if we need more than that, we have to configure a separate uh, scale units. So you can define your BGP, you can create your new key pair, or if you have your existing key pair, which is stored in an Azure, you can select that. So I already have one. Let me hide this. Okay, and then I can go next. Here I can define a version. As I said, currently the minimal version is 81.10, but you can go with 81.20. In my lab, I configured everything on latest version, 81.20. So as I said, the license type is right now only NGTP. Okay, there's no, and again, pay as you go option. Okay, so threat extraction blade currently is not supported. Okay, and there's no BIOL option. And if you see the user, so I usually prefer bash. Okay, this your choice. You can define your specific keys, SIG key. Okay, so I don't want to connect with my smart one cloud, so I'll skip this and then review and create. So as soon as I click on review and create, it will review, and then it will create the NVA for you. Okay, I already did that in our hub. So the setting is straightforward. Okay, it will not going to take more than 5 minutes. It will deploy uh, your NVAs within the hub, and if you go to hub, you will see those particular new NVAs. Okay, and I can go under my hub, and as soon as my deployment is gets completed, you will able to see those particular NVAs. Okay, vWAN, NVA1, okay, another NVA. So in my environment, I configured two NVAs. Okay, one NVA I dedicated only and only for east-west traffic. Okay, east-west NVA, and one NVA I dedicated for egress traffic towards the internet. Why I did that? So normally there is a best practice which usually most of enterprise customers follows, the segregation of duties. So I know, this one firewall is I dedicated only and only for egress traffic, one firewall I dedicated for ingress, and one firewall dedicated for my east-west traffic. So one traffic can't be affect the other traffic. That is what the common goal here. So you can do that. Okay, so I configure this too. And the second piece of this particular configuration is you can go to intent route. Okay, and as soon as the NVA is done, you know that I configured two firewalls, two NVA appliance, two scale units. Okay, so I mentioned internet traffic go via my NVA1 V1 NVA. Okay, and my east west traffic, which is private traffic, all my RFC ranges 10 series, 172, 192 series. Okay, I say go via my east west NVA. Okay, so the inspection for private traffic is going to happen via east west NVA, and my egress traffic is going to happen via my V1 NVA. Okay, that's really important, and I configured within the single hub only. So within single hub, I configured two scale units for two different purpose. Okay, now another question here is the upgrade part. So right now only two versions are there, R81.10 and R81.20. Now we have to there's a new future, might be there's a new version will come. Okay, might be R81.40. So the process is straightforward. Okay, I will configure NVA again, the steps of which I showed you. Okay, and then I will update my intent route. It will take only couple of minutes, and your part is done. So there would be some couple of minutes downtime for this approach, but upgrade would be smoother. Okay, so this is how we can manage the upgrade procedures as well. Okay, we can't do in place upgrade for vWAN, because as I said, it's a platform service underlying managed by uh, Microsoft. Okay, so this is how you're supposed to follow the upgrade procedures as well. Okay, we'll talk the ingress flow as well. Okay, so if you see my PPT, okay, there is we discuss on this hub. Okay, let me just put it into PPT mode. So we saw the hub configuration. So here we have a two scale unit, CGNS, internal scale unit 1 and scale unit 2. Okay, and my VNets, which is paired with my vWAN hub. Okay, plus I also configured a separate VNet only and only for egress traffic flow. Okay, so let me just show you that as well. So let me just go to load balancer. So this is what load balancer got configured automatically, front-end load balancer, because I just wanted to monitor my front-end traffic only. Okay, or ingress traffic only via that same firewall. So if you see my backend pool, so backend pool is checkpoint VMSS gateway. So right now I configured only one gateway as a part of VMSS, but you can configure 2, 3, 4, 5. Depends upon the configuration, and it's currently running in environment. And what I did, I expose my applications via front-end IP of load balancer. This is what the front-end IP of load balancer: 52.154.203.244. So I expose my applications via this particular front-end load balancer IP. So I created one simple load balancing rule here. If you see that, so we'll say this is what my app one rule. It will front end, it will listen on this particular front end IP. Okay, and this load balancer is listening on port 80. It will send that traffic to checkpoint firewall, my backend port, which is 8080. This is what my backend port. That is where checkpoint firewall is going to listen that particular traffic flow. Okay, and this is what help group 8117 gets configured between LB and checkpoint VMS's gateways. Okay, and the backend application is also listening on port 80. Okay, so this is what configuration I did. Now let's go to our management console, the smart console. So this is what my smart console. Okay, and here if you see, I onboarded multiple firewalls. So this is what my egress NVA one egress NVA 2. This is configured within the vWAN architecture, and I will show you how exactly we onboard it as well. Not manual, everything is automated. This is my east-west NVA. Okay, two NVAs are there, two scale units I configured, and third I configured the ingress scale unit. So all got onboarded automatically via checkpoint CME. Okay, how exactly it happens? Okay, so and first of all, you understand the CME concept, correct? Let me just understand what CME is. It's a cloud management extension. Okay, which allow the automation on in terms of onboarding respective security gateways on checkpoint smart console. Plus it will also push the configurations on respective gateways. Okay, configurations like blades, if you wanted to push any hardening script. Okay, if you wanted to push policy packages, you can push it via CME. Everything can be automated via CME. Okay, and another good use case here is, because those are VMSs, again it's a dynamic object, again these are NVAs are again multiple objects which is working in an active manner. So we have to manage and maintain uniformity across the gateways. So CME will make sure that. Okay, so let me just show you the CME configurations as well. Let me just take the access of management server, put the access. So this is what my management server. Okay, so how I onboarded my vWAN gateways. Okay, there's a command called CME menu. Okay, so this is completely interactive first of all. Okay, if you see that, as soon as you configure CME menu, it will show multiple controllers. What? Azure, AWS, GCP. So right now my CSP platform is Azure, so I will select option 1, Azure. So here I wanted to integrate vWAN, so I'll click on option 2, which is vWAN. Okay, then I wanted to configure NVA, which is deployed on vWAN. So I will select option 1. Here now I need to configure tenant ID. You know that Microsoft tenant ID, you have to configure that tenant ID. So my tenant ID is already here. This is what my tenant ID. So I will just copy this and I'll paste it here. Enter. It will ask my client ID. So we have to register applications, correct? Done. So I will config. I'll just copy paste my client ID. Done. Then my client secret. This is for authentications. So I will configure my client secret. Okay. Then my subscription ID. SB is my subscription ID. Then you will manage our resource group. So I showed you, correct, that resource group which we need to save. Because my CM will come to know they have to reach to this Azure vWAN resource group and search. You have to type your NVA name, which we configured there, test NVA, and you have to type SIG, which we defined in our Azure template. Okay, you can configure your policy. So it will push this policy automatically to NVA, and then done. As soon as click on one, yes, then configuration will complete it. And as soon as the configuration will get complete, it will see all your gateways which is belongs to the vWAN. It will display here. So I configure this egress NVA1, egress NVA2, east west via this CME automatically, and it will happen. It will see continuously to you. Okay, there is no manual onboardation, because if it is a 40 GB PS throughput, then there would be a multiple scale units, or that gateway gets configured automatically. We can't do it manual onboarding. So this is why we build this EME concept for vWAN as well. Okay, I hope you understand. Um, then what we'll do, let's simulate the traffic flow. Okay, how exactly we are inspecting a traffic. Uh, Let me just take the access of my one of the spoke VM. Let's first we'll see our egress traffic flow. Okay, this is what my spoke VM. Okay, and this spoke VM, if they wanted to access internet, okay, might be google.com, and my intention here is I need to enforce that particular traffic via checkpoint firewall inspection. Okay, because I already did the peering, and the if you see the effective routes, it is going towards the checkpoint NVA. Okay, and even I will show you the effective routes as well, but I just wanted to show the communications. Is it working or not? Ping 8.8.8. So the communication is happening. Now I just wanted to see is traffic is hitting on checkpoint firewall or not. I'll go to smart console, logs, and I'll just show you the configurations as well, network configuration. The Ethernet 0, it has only one interface, and the IP address is 0.4, 192.168.0.4. Let me just see destination as 19, sorry, 8.8.8.8. Yeah, so there's a traffic. So if you see my time, 12:56:54, the origin is NVA and it's coming from the 0.4 pointing towards dnsgoogle.com. So yes, we can able to see the traffic flow on gateway. Okay, it is getting inspected my egress NVA1. So because in my intent route, I clearly mentioned any internet traffic, it's supposed to go by egress NVA1. Okay, that's the egress traffic flow. Let's talk the east-west traffic. The traffic between this VNet 1 to VNet 2. Okay, this spoke VNets, between spoke VNets. So we need to intercept that spoke VNet traffic. Okay, so I configured one more VM in another spoke, and the IP address of that particular VNet VM is 192.168.1.4. So I'll just try to ping the VM which belongs to other spoke VNet. Yeah, I can see the response back. Now let me just see the traffic which is seeing on firewall or not. Again, let me just see the destination is 192.168.1.4. Yeah, I can see the traffic 1258. Again, if you see my source is my application, the spoke VM 0.4. Destination is my another spoke VM 1.4. Okay, and my service is eco packets ICMP. So right now we are doing VNet to VNet interception, but some customers also ask me, can we do a subnet to subnet interception as well? This is doable, but it's quite tricky. We have to configure the manual UDR, okay, at the subnet level, and we have to point a default subnet traffic towards the front end IP of internal load balancer. Correct. So which internal load balancer, if you see the architectures, when we configure any NVA, by default it gets they configure the internal network load balancer along with that, and the job of that internal load balancer is distribution, traffic distribution, and this internal load balancer has a front end IP. Okay, so you have to configure a specific UDR route at the subnet level, and then we can ingest or intercept that particular traffic or forward that particular traffic within the subnet as well, not within, across the subnets which is present within the VNet, pointing towards the checkpoint NVA which is configured in the vWAN hub. Okay, so that's a second type of traffic. Last but not the least, which is your incoming traffic. As I said, I expose my application via the front end load balancer IP 52.154.203.244. Okay, so I can just, yep, I can able to access that particular traffic that I deploy one Apache server, HTTPD server on my virtual machine. Let me just see here. Again, my destination is, because my Apache server is configured on my 0.4 VM. Yep, I can see this particular traffic, which is, it's coming from the VM, that checkpoint ingress scale unit, and destined towards my destination 0.4, and service is HTTP TCP/IP. So for that, I simply created one NAT policy. Okay, I just wanted to show you quickly. I Because last 10 minutes, I just wanted to see if you have any kind of queries. In next few minutes, I will conclude the lab session, and then I will address all your queries. Okay, so to do that, I just simply created one NAT policy, and I just wanted to show you what NAT policy I created. So I created a separate package altogether for my ingress traffic flow policy. So I click on ingress, and if I go to NAT, so if you see that I created one simple policy, because right now my load balancer is the network load balancer. So that's why I mentioned original source as all internet, because I can see the source IP. Checkpoint can see the source IP. If it is the application load balancer or reverse proxy, then we have to mention accordingly here. My original destination is local gateway external. I created one dynamic object because the VMSS is dynamic. I can't mention the static IP, because it's not static, actually it's a dynamic object. So I mentioned object called local gateway external. Okay, so checkpoint has this object local gateway external and local gateway internal, which represent ethernet 0 and ethernet 1 arm of VMSS. My original service, the firewall is going to listen on 8080 port. That is what we configured under load balancer rule. Okay, so that's why we mentioned 8080 port. So here I hide the traffic. So when traffic leave that checkpoint VMSS gateway, we're supposed to hide that traffic, because return traffics have to go via same firewall or same VMSS gateway. So we hide that particular incoming traffic behind the local gateway internal object, which is another dynamic object. And my translated destination is the server where Ubuntu is configured. My Apache is configured. So that is what I created, host object. And that my Ubuntu server and my Apache server is also listening on HTTP port 80. So that's why I mentioned translated service as HTTP. So this is how I simply configured a NAT policy. My policy right now, access policy is simple right now, because it's a testing environment. I allow any, but you can create a specific policies as well. And I publish and install the policies to respective gateway. So this is how I configured it. Okay, and the most important as a part, as I said, the CME configuration. Okay, this is really important, because this will help you to automate the many processes. And again, that is what another, I can say, the uniqueness within the checkpoint deployment. And you see that how easy it is in terms of ingestion and the configuration of checkpoint firewall within the vWAN hub. Okay, so some, okay, so one which I wanted to show you here. So there would be, okay, so right now, as I said, only two types of intent route, internet traffic as well as private traffic. There would be a third intent route will gonna come soon, which will suffice, or it will fulfill our ingress traffic flow. So right now the ingress traffic flow is not supported or GA in current environment, but yes, it's gonna happen soon, and you will see that here. But till that time, we still have a workaround. As I said, we can configure a separate egress VNet to inspect your ingress traffic. So with this, we can able to conclude all types of use cases via single hub architecture. Okay, while inserting a checkpoint NVA within the core fabric. So what I will do now, I'll just stop my screen, and I'll just see if we have any queries, because 10 minutes are left. So I just wanted to see if you have any queries, any feedback. Uh, it would be really helpful. Jonathan?
Yes, sir, Rupesh. So I didn't see any questions on the bridge, and that obviously means that you explained everything very well. Thank you very much. All I have to say at the end is, firstly, thank you to everyone for joining us. Thank you, Rupesh, for the expert presentation. Please feel free to contact us at any time, whether it's going to be Rupesh directly in APAC or me in headquarters, for any additional deep dive content, whether it be CloudGuard network security, whether it be anything else in CloudGuard. We'd be happy to help. And we thank you for participating. Thank you, Rupesh.
Thank you so much. Thank you, everyone. I hope this session was quite clear most of the concepts regarding vWAN, and most importantly, how easy it is to integrate with Checkpoint, and how easy it is to replicate multiple use cases via central hub architecture. And I can say one thing about this vWAN and checkpoint insertion within this overall vWAN and architecture is, so it is actually a revolutionary, which is simplifying most of the operational efforts which our network admins and security admin is doing day by day. Okay, and that is what the pure goal here, the operational excellency. Okay, and that is where Checkpoint and Microsoft are committed together to serve our customer. So thank you so much, everyone. Thank you once again for active participation.